Hi, I'm Dirk Ducharme, and welcome to Technorazzi. In this segment of our series, inspired by you, our viewers, we've gone back to CPM Labs in Rancho Cordova, California. This week, Craig Howell will teach us all about surface roughness measurements. So now we're in the lab with Craig Howell of CPM Labs, and today we're going to look at, I think you call this profilometer, right?
Profilometers, some call it surface roughness gauges.
And what does it do?
Well, it measures the roughness of the different metals depending how they're machined or ground. Sometimes the blueprints will call out a spec. Usually it's roughness average, RA.
So this is the actual, with the surface of the material, how shiny or smooth or whatever it is?
This is the roughness of the surface that has been produced by the machining or grinding or polishing. There will be specific requirements of what it should measure. This will measure them. This is a portable unit. It's called a Mitutoyo surf test. There's a similar unit made by Mar Federal, which is called a pocket surf, variations of it.
And they all operate basically the same way?
They pretty much do. They run a stylus or a tracer across the surface. Inside it does all the math and produces the different parameter of roughness you're looking for. There's probably 20 or 30, but typically the ones used mainly on the floor are roughness average, RA. There's RQ, root mean square. There's RY, which is a maximum roughness peak to peak. And RZ, which does that peak to peak in 5 or 10 segments and averages them. Setup on these is very important. Being portable, a lot of times the tendency might just be to set it down, take a number and go. This stylus travels in and out. It has to be perpendicular to the lay of the roughness. If it's not, that tracer is still going to hit the top of the mountains, but it's not going to go all the way down to the valley. It's going to start up the next mountain before it gets there.
So you actually have to know kind of the grain, so to speak, of the surface that you're measuring.
You do. We always give a very hard look at the surface before we start to determine where are the lines, and then set up perpendicular to it. And we don't take one trace, we'll do several. We'll take a trace, then we'll slightly skew it one direction, and we'll slightly skew it the other direction. The highest number wins. Now there are several things to consider when you're setting up, and they're found on the back of this unit. The first one is, what are you measuring? RA, RZ, or R max is what the choices are in this. Typically RA is what is used. Then are you using the ISO JIS specs or using DIN, which is a German spec? Typically it's the ISO JIS. And do you want your readouts to be in millimeters or in inches? We use inch. It can be either direction. One of the most important is the cutoff frequency. The cutoff frequency, which one you choose, you have 3 choices. It's determined by the roughness that you're going to be measuring.
Okay.
Use a higher cutoff frequency for the rougher, and you would use a lower cutoff frequency for the finer materials. What it's doing is filtering out random noises, waviness, things of that nature. And if you're set up with the wrong cutoff frequency, your numbers will be meaningless.
Okay.
A question we get asked a lot is, why do you calibrate up at 116, 118 when we're measuring something down in the range of 4 or 8? And the reason really, it comes to percentage of error. If you are a little bit off on this 118 or 116, as far as if there's any dirt, if there's any contaminant, if you're not entirely perpendicular, if there's any vibration during the measurement, it's easy to be off by 1 or 2 numbers, 1 or 2 millionths in this case. 1 or 2 millionths at 118, if you divide the two, is a lot less significant than if you were to calibrate down to the 4 or the 8 range. If you had a difference of 1 or 2, that can be 50% of your reading. What we'll do is press the start button, the stylus will move, and it's taking 5 segments typically for RA. 5 segments, and then it'll average them. So I'll push this, and the stylus just moves very, very slowly across, and it comes out with a number for RA. Now we're set up on a standard. We know this is 116.6 microinch. It showed at 115, so we have to reset the gain a little bit. Okay, now we're going to turn the gain screw a little bit higher because it's reading low. This is 116.6. This only resolves to the single million, so we're going to set this up to read 117.
So this is what you would do if you were setting it up, just prior to setting it up?
Right when we start off. The first thing you do is check it with a standard. Most of them are the single patch standards that come with the units. They're sent to the calibration lab also. A lot of times they'll be different than they're marked. These are what they're marked. Ours are marked to the 10th of a millionth. We're going to do this several times till we get the maximum reading, and that'll be our basis.
So you rotated it a little bit.
Just a little bit to the side. We'll go a little bit.
So you're trying to find where the maximum reading comes from.
A little less, so that means we're going the wrong direction. The highest number will be the true number for RA in this case. Anytime you change probes, you have to reset the gain. That's not a defect in the probe, just different probes have different impedance or whatever the case. Now we're set at 117, so this is now set for use.
Okay.
In a calibration lab, what happens is this stylus will typically wear. That is the part, other than physically damaging the unit, the only part that really wears out is the stylus.
Okay.
As it rubs and rubs and rubs, it eventually loses some of its shape. So we will check the stylus with the other patch, with the finer patch. This one happens to be 15 microinch. As the stylus wear, they typically will read a lower number. They're typically flattening out some.
Okay.
And there is a limit to what they're allowed to wear to before they need to be replaced.
So the process then is, if I understand this right, you put your reference standard in there, you take a measurement, and you adjust the gain so that what's showing up on the display matches what the reference standard says it's supposed to be.
Yes, now you're set to go.
And then you're set to go, and then you can put your material under test.
Then you would put the part to be measured.
Okay. So is there a rule of thumb as to what range you should be calibrating in based on the material that you know you're going to be measured?
No, you always use the provided standard, which is usually 116, 118, somewhere in that range.
Okay.
Sometimes 120. You'll find they're all manufactured there, and that's where the machines are set up. Then if you're measuring a finer surface, you'll reset the cutoff to match, but your calibration and your gain is set to the higher numbers.
Okay. Now what about any special considerations in taking care of the equipment?
The most fragile part is the working surface, which is the stylus. These are replaceable. These probes do come out. They used to make just replacement stylus, but you had to get inside and resolder them. Now you just buy a new probe.
Okay. All right, there you go. Profilometer, Craig Howell, CPM Labs.
Three, two, one, fire.